to our introduction to descriptive statistics. In this video, we'll explore the fundamental concepts of descriptive statistics, which is a branch of statistics that focuses on summarizing, organizing, and presenting data in a meaningful way. So, what exactly is descriptive statistics? Descriptive statistics involves methods of organizing, summarizing, and presenting data in a convenient and informative way. The main purpose is to describe the main features of information collected in a quantifiable way. Before we dive deeper, it's important to understand that descriptive statistics differs from inferential statistics. Descriptive statistics focuses on summarizing and describing the actual data we have collected. In contrast, inferential statistics uses that data to make predictions or inferences about a larger population. For example, a descriptive statistic might tell us the average test score of a class, while inferential statistics would help us predict how students in general might perform on similar tests. In this video, we'll be covering several important aspects of descriptive statistics. We'll discuss data types, measures of central tendency, including mean, median, and mode, measures of dispersion such as range, variance, and standard deviation, data distribution, and finally, data visualization techniques. Let's begin with an overview of data types. In statistics, data can be classified into different types, which determines how we analyze it. We have qualitative or categorical data, which represents qualities or characteristics. Examples include colors, gender, or yes/no responses. On the other hand, quantitative or numerical data represents quantities that can be measured. Examples include height, temperature, or test scores. Numerical data can be further divided into discrete data, which involves distinct, separate values, like the number of students in a class, and continuous data, which can take any value within a range, such as weight or height. Now, let's move on to measures of central tendency, which help us understand the typical or central values in our data. The three main measures of central tendency are the mean, the median, and the mode. The arithmetic mean, commonly called the average, is calculated by adding up all the values in a dataset and dividing by the number of values. For example, if we have the scores 70, 80, 85, 90, and 95, the mean would be the sum 420 divided by 5, which gives us 84. We can think of the mean as the balancing point of our data, like a fulcrum that balances all our values evenly. The median is the middle value when all data points are arranged in order. If we have an odd number of values, it's the middle one. If we have an even number, it's the average of the two middle values. For our example, when we arrange 70, 80, 85, 90, 95 in order, the middle value is 85, so that's our median. Lastly, the mode is the value that appears most frequently in our dataset. If we had the values 70, 80, 80, 90, 95, then 80 would be the mode since it appears twice while others appear only once. Some datasets might not have a mode if all values appear with the same frequency, or they might have multiple modes if several values tie for the highest frequency. Let's discuss when to use each measure of central tendency. The mean is the most commonly used measure and works well with normally distributed data. However, it can be heavily influenced by extreme values or outliers. The median is less affected by outliers and extreme values, making it useful for skewed distributions or when dealing with data like income or house prices where extreme values are common. The mode is particularly useful for categorical data where calculating a mean doesn't make sense, such as finding the most popular shoe size or most common blood type. Let's see an example with outliers. Consider these 7 salaries: $40,000, $45,000, $48,000, $50,000, $52,000, $55,000, and $200,000. The mean is greatly affected by the $200,000 outlier, giving us about $70,000, while the median of $50,000 gives a better representation of the typical salary. Now, let's move on to measures of dispersion, which tell us how spread out our data is. While central tendency tells us about typical values, dispersion tells us how varied or spread out the values are. The simplest measure of dispersion is the range, which is just the difference between the maximum and minimum values in our dataset. For our test scores example of 70, 80, 85, 90, and 95, the range would be 95 minus 70, which equals 25. A more sophisticated measure is the variance. To calculate variance, we take each value, subtract the mean, Square that difference, then find the average of all those squared differences. The standard deviation is simply the square root of the variance, and it's often preferred because it's in the same units as our original data. Let's visualize what standard deviation means. In a normal distribution, approximately 68% of the data falls within one standard deviation of the mean, 95% within two standard deviations, and 99.7% within three standard deviations. This is known as the empirical rule, or the 68-95-99.7 rule. Let's compare two datasets with the same mean but different standard deviations. A small standard deviation means the data points are clustered closely around the mean, while a large standard deviation indicates the data points are spread out over a wider range.